So we're going to look at some examples and then applications of using right triangle trigonometry. Let's start with a fairly straightforward problem. We have a right triangle. We want to solve for x and y. We want to find the missing sides. Now, the important thing to understand is that we're looking at a 60-degree angle here. And so that means that this one must be 30 degrees. And in a 30, 60, 90 triangle, we know that there's a relationship with the three sides. And from what we've learned about the unit circle, if you picture a unit circle, here's 60 degrees. We know that the cosine is 1/2, and the sine is the square root of 3 over 2. And the hypotenuse is 1. So in that triangle, a 30, 60, 90 triangle, where this is 60 and this is 30, if that's 1, the side across from 30 is half of the hypotenuse, and then the longer leg is the shorter leg times the square root of 3. And so that relationship can help you solve these 30, 60, 90 triangles. So let me draw an arrow here. So we're given the hypotenuse is 18. So that means that if I take the side across from 30, which is the x in this case, that's going to be half of the hypotenuse. So this is going to be 9. So x is equal to 9. And then for the longer leg, which is y, the longer leg is always the shorter leg times the square root of 3. So I'll just multiply x times the square root of 3 to get y. And we get y equals 9 root 3. Now, that was the easy example. Let's look at one where it's a little trickier. Once again, we have a 30-degree angle, so we know this one must be 60. So we have a 30, 60, 90 triangle. And remember that the side across from 30 is half of the hypotenuse, but we don't know the hypotenuse. And we don't know this side. So if we knew one of these two, that would make it easy to find the other one. If this was 10, that would be 5. If this was 5, that would be 10. And then we take whatever this is and multiply by root 3 to get this. But we do know the longer leg, the leg across from 60, and it happens to be 60. So I know that if I multiply the shorter leg times the square root of 3, it should equal the longer leg. So I'm going to have to write an equation and solve this. So the shorter leg times the square root of 3 equals the longer leg. So now I can solve for b. And then I'm going to rationalize this. Multiply by root 3 over root 3. And I get 60 root 3 over 3, which can then be reduced to just 20 times the square root of 3. Now, once I found the shorter leg, I know the hypotenuse is twice as long as the shorter leg. So I just need to multiply b by 2 to get my longer leg. So c is equal to 40 times the square root of 3. So don't think that the longer leg always has to have a number that's the square root of 3. Now, on the other hand, it would have been really easy if I said this side was, for example, 60 root 3. Well, then you know that this side would be 60, and then this would be 120. So, all right, now let's look at some applications. A surveyor is standing 50 feet from the base of a large tree. She measures the angle of elevation to the top of the tree at 71.5 degrees. How tall is the tree? So if a problem does not give you a picture, the first thing you want to do is draw a picture. So we've got a person that's standing 50 feet away from a tree, assuming it's straight up. By the way, let's put our units on here, 50 feet away. We don't know how tall the tree is. I'll call that x, or t would be appropriate, I guess. And this is the angle of elevation right here, from the ground up to the line of sight to the top of the tree. So that's what they mean by angle of elevation. And so that's 71.5 degrees. And we're going to have to assume that this makes a right triangle, otherwise we wouldn't be able to do this. And so now we have to find out how tall is the tree. So we want to find out x. So looking at this problem, we need to figure out let me draw an arrow, what do we need to use? Sine or cosine or tangent? Well, here's the angle we have, although we could figure out this one. So with this angle, this is the opposite leg and this is the adjacent leg. So that would call for us to use the tangent. So we're going to say the tangent of the angle, 71.5 degrees, is equal to the opposite leg over the adjacent leg. And so now we have our equation, and we're going to solve this for x. Simply multiply the 50 to the other side. So 50 times the tangent of 71.5 degrees. And we're going to need a calculator. So we want to make sure, first of all, that we're in degree mode. And this one isn't, it was in radian mode. So now we're in degree mode. And so now we do 50 times the tangent of 71.5, and it's in degrees. So we get 149.43. It didn't say how far to round it, so we'll say 149.4 feet. 149.4. And the units were feet. And that's the height of the tree. And that's what they wanted. How tall is the tree? So that wasn't so bad. Let's look at one more. You are 150 yards from a river. So let's draw this. Here's my river. You're 150 yards away. So let's put you right here. And this distance straight to the river is 150 yards. Rather than walking directly to the river, you walk 400 yards. So you're walking on an angle along a straight path to the river's edge. So something like this. And that's 400 yards. So now we've got a right triangle. Find the acute angle between this path and the river's edge. So between the path and the river's edge, that would be here. Let's call that angle theta. So now we need to solve for theta. So now we're solving for an angle, not one of the sides. So this is a little different. So when we look at our picture here, let's see what we're dealing with. So in terms of this angle theta, we have the opposite leg and we have the hypotenuse. Opposite and hypotenuse. That's the sine function. So we're going to write an equation for sine. So we'll say the sine of theta is equal to the opposite, which is 150 yards, over the hypotenuse, which is 400 yards. Now here we need to solve for theta. Theta is inside the sine function, so we need to undo that. We need to do what's called the inverse of the sine function. And so theta is going to equal, and we're going to talk more about the inverse trig functions shortly. But the notation, just like you would do for the inverse of a function f, you do f negative 1. We write sine negative 1. That doesn't mean 1 over the sine. That means the inverse of the sine function of 150 over 400. So instead, normally you take the sine of an angle and get a number, which represents the ratio of the opposite leg to the hypotenuse. Now we want to take the inverse sine of the ratio, and that should give us the angle. So we're going to need a calculator for this, because that's 15 over 40, or 5/3, and that's not one of the ratios we know from the unit circle. So we're going to have to grab our calculator, and once again we want to be in degree mode, which I know we are already. And the inverse sine, you can find it above the sine key, so it's second sine, and then we punch in our ratio, and it's going to return to us the angle. we'll say 22.0 degrees. So the angle it makes is approximately 22.0 degrees. And that's it. So problem set, there's some from 4.3, and then there's one more word problem from 4.4.